Alright, today we're going to try to build a piece of this Tumblr robot from the Vex kit. This curriculum map is pretty old, coming from Autodesk, where there's a lot of components where we're taking the actual Vex components that are already made and then trying to assemble them into cool robots like this. So let's get started in Inventor, where we're going to work on an assembly. Inside that document, if you move a couple pages down, you'll find that it gives you a really great step-by-step procedure, and this is all we're going to aim for in this video. Let's see if we can assemble these 10 pieces. 10 plus the chassis. So here we go. On Inventor, I'm going to start an assembly. So I have an assembly already open, and I'm going to start placing pieces from an existing library. So my library is placed in a specific place to help me find it. And I'm going to start in the structure category where I can find that chassis rail 16 hole. It's in a tad bit of an awkward orientation, so let's take a look at this thing to see what we can do. It's going to require a couple rotations. So this can be a bit confusing, but it's a really good exercise for students to think this through, where there's probably more than one answer. But let's see what happens if I rotated this thing about Y to get started. How am I compared to the orientation that I'm looking for? So right now this thing would be upside down. So if I rotate this thing about my z-axis, let's see if I did that twice. That gave me a rotation that gave me the orientation that I was looking at. So it's a neat exercise for you to stop and think about it. How do I rotate that thing about an axis to give it the orientation that I'm looking at? And the goal ultimately is to see if we can just mimic this to make our life easier. All right, I need two of these bearing blocks. Let's see, or bearing, they call them bearing flats. And then I need 1-inch standoffs. So let's see what else is in my library directly in front of me. So I do have the 632 and 832 1/4-inch screws. In the document, it's asking for 832 1/4-inch screws. So let's go in there and pull in two of those guys. So I've got a 1/4-inch screw, and they're going to go on the back side right like that in the proper orientation. So I'm going to escape out. Got those done. Next thing I'm looking for are some standoffs, the bearing flats, and then those, what do they call them? The bearing rivets. So go back to the place, the library. Here I can find my 1-inch standoffs. Let's bring those guys in. So I'm going to place those guys up front because they're going to go on this side. And then let's see if we can find our bearing flats. And it does not look as though they're in this one, but I do have my pop rivets, so let's maybe plop those. I'm going to do a quick z-axis rotation just to place those so that they're ready to go when I'm ready for them. So let's see if we can find those bearing flats. They're in a different library apparently. So let's get out of structure and into motion. And let's see, here we go. In motion, I see these guys, and I'm going to rotate them about Y. So I'll put them right there. So once we understand how these parts come together within Inventor as an assembly, it's pretty doable where I want things to line up. Circle on circle is pretty straightforward. But Vex is square, so they've created these things called imates in order to make an insert a much easier process. So let's take a look at our document to see what we're going to try. Let's try something straightforward like these 1-inch standoffs. And it looks like those guys are going into the 1, 2, 3, 4, 5, 6th hole from each edge. So if I identify that chassis rail and count over 1, 2, 3, 4, 5, 6. This little white dot here is an IMate that's going to help me do an insert. Now, all I want to do is insert. So if I activate, it'll be more obvious when I activate this thing. So if I go to this constraint and say insert two things into each other, it doesn't have to be actually inserted each other. Let's think about this for a second. So if I take that circle and I moved it and inserted that into another circle, those two circles would align. So if I take that circle and I say in my 6th hole, I want to insert into that square peg. That square peg's a nightmare because a square and a hole aren't necessarily compatible. But because we have this white dot on here, I can now just press that dot and it happens automatically, which is brilliant. So then I just press apply and it gives me one completed joint. If I count out 6, the one thing you do have to make sure that you have before you start your constraint is that make sure you have your IMates, those little white dots, activated before you start your constraint. So again, go to insert, count over 6, 1, 2, 3, 4, 5, 6. I'm going to take that guy and then find my circle. And I'm going to press, on this one, I'm going to press cancel because I was a bit of a space cadet. I don't want this chassis rail just to fly all over the place. I would like that guy to be the grounded element in my assembly so that something is holding everything fixed in place. So if I activate that guy again, let's go back and fix my error. I'm going to go constraint. I'm going to go insert 1, 2, 3, 4, 5, 6. That guy there, circle there. You can pick the wide one or the small one or the large one. And if I apply it, I now have 2 of my standoffs in place. Let's see. I'm pretty sure that on the other side of this constraint, these 6 or 832 bolts that are supposed to go inside that space right there are going to work almost identically to what we've already done. And then notice that this bolt actually has an IMate built into it too. So if I go constraint, first of all, activating my rail, I'm pressing constraint. I'm going to hit insert and I'm going to say, hey, there's a bolt that needs to be placed there. And then I can do it 2 ways. I could actually just pick the circle and press apply, or I can actually activate the IMate. In this one, let's try that, where I make sure with the control button that I've selected my chassis rail and I've selected my bolt that's going to be inserted into there. Now I activate my constraint and press insert. I can hit this IMate. I'm going to hit that IMate, and the 2 are locked together. I just have to press apply. All right, we're making progress. Let's try these bearing flats. So once again, let's go to our picture and see what we're trying to do. We only have 1 space before we put in the bearing flat. So I'm going to go into that 2nd hole and align it to the 1st hole of the bearing flat. So I'm going to activate the chassis rail. I am going to say, hey, I want to insert using one of those IMates. I'm going to bring that guy closer. So I'm going to activate my constraint now, press insert, and now I can find that guy and align them to, let's see if I can just rotate that so that we can see where that circle actually is. So I'm going to press apply, but then cancel so we can see what just happened. So I've only constrained half of this bearing flat. I want to do the other side as well. Now that I've activated that bearing flat, you can see the IMates on it. So I'm going to go Control, left click, and then I can lock in the next insert constraint. So if I press Insert, grab that IM8, grab this IM8, and press Apply. Let's just rotate backwards and see if we're convinced. So it looks like all those holes are lining up really well. Everything seems to be constrained properly as it's being aligned into its proper slot and hole. Alright, so let's zoom in on our last one. I'm going to skip that one. I'm going to do Control left click again, where I'm going to do a constraint with the Insert button. Press that guy together with that guy. Press Apply, and then cancel out and drag them down. I'm going to control it, bring out my constraints again, and press Insert, and then this guy together with, I'm just going to be careful and rotate him around to see if I can find the proper other side. So let's take a look. Wonderful. Now the last thing we notice is that these extra pieces here that they call the bearing rivets need to be placed. So let's try that as our final step here. And I just noticed for the first time ever that the bearing rivets actually have an IM8 as well. So if I go to the back here and take one of these rivets, the holes for those guys are going to be, we're going to leave the center hole vacant. So if I click on that guy and click on my chassis rail, activate Insert, I'm going to click on that guy and that guy, and it's a done deal. Get my IM8s active, get my little rivet guy active, activate the constraint, do an insert, and find that guy, and it's all set. Let's finish it. Chassis rail, first rivet. Gonna constrain it, insert that guy and that guy, and then last one, constrain. I've got my insert that and that, and we're all set. So I was able to get quite a number, 11 total parts in this assembly done in a relatively reasonable period of time. So then I would just carry on with that piece being added to over time to end up forming the left side chassis. I think that would be a super cool final goal, if not the full robot, at least get one of the sides done. That looks super cool to be able to generate. So in the next video, I'll keep going and see how far I can take it.